In 2016, Google DeepMind built a program called AlphaGo to play the ancient board game Go. Go has more possible positions than atoms in the observable universe. No human could teach it every strategy. So they didn't try. Instead, they let the program play itself millions of times, and every time it won, it learned something. Every time it lost, it learned something more. Then it played Lee Sedol, one of the greatest Go players in history, and won 4 games to 1. But the moment that changed everything wasn't a win. It was move 37 in game 2. A move so strange that commentators thought it was a mistake. It wasn't. It was a move no human would ever conceive of. AlphaGo had discovered something new about a game humans had played for 2,500 years. That's reinforcement learning in action. And it's the reason the most powerful AI models in the world today aren't just trained on data, they're trained to think. So what is reinforcement learning? Strip away the math and the jargon, and it's the simplest idea in all of AI. You have an agent. That's the thing learning. It exists inside an environment. That's the world it operates in. The agent takes an action. The environment responds with a reward signal, a number that says how good or bad that action was. And the agent's entire goal is to maximize the total reward over time. That's it. An agent, an environment, actions, and rewards. Think of it like training a dog. You don't explain sit in English and expect the dog to diagram the sentence. You say sit, and when the dog sits, you give it a treat. The dog doesn't understand language. It understands that sitting leads to good things. Reinforcement learning works the same way, except the dog is a neural network, and the treat is a mathematical reward signal. Here's the hard part. The agent has to figure out what to do without anyone telling it the right answer. In supervised learning, you show the model thousands of labeled examples, this is a cat, this is a dog, and it learns the pattern. In reinforcement learning, there are no labels. There's no answer key. The agent has to explore. It tries things, watches what happens, and adjusts. This creates a fundamental tension called the exploration versus exploitation trade-off. Exploitation means doing what you already know works to get reward. Exploration means trying something new that might fail but might also discover a better strategy. Too much exploitation and the agent gets stuck in a mediocre routine. Too much exploration and it never settles on anything that actually works. The best reinforcement learning systems balance both. They explore when the situation is uncertain, and exploit when they're confident. That's what AlphaGo did. It explored millions of self-play games, found strategies no human had ever seen, and then exploited them to win. So why does this matter for language models? Because reinforcement learning is the secret ingredient behind the most capable models you use today. Here's the problem with traditional training. A language model learns to predict the next word from internet text. That gives it knowledge, but not judgment. It can generate a fluent sentence about any topic, but it can't tell you whether that sentence is actually helpful, actually safe, or actually correct. You need something to teach the model the difference between a response that's merely plausible and a response that's genuinely good. That something is reinforcement learning from human feedback, or RLHF. The idea is straightforward. You show humans 2 different responses to the same question and ask which one they prefer. Do this thousands of times, and you train a reward model, a separate neural network that learns what humans consider good. Then you use that reward model to train the language model itself with reinforcement learning. Let's walk through exactly how RLHF works. Step 1. Start with a language model that's already been trained on text. This is called the base model. It's smart but undisciplined. It will happily help you write code or help you write malware with equal enthusiasm. Step 2. Collect human comparisons. Show people 2 responses and ask which is better. Thousands of these comparisons, across many topics and tasks. Step 3. Train a reward model on those comparisons. The reward model learns to score any response on a scale from terrible to excellent, based on what humans actually prefer. Step 4. Use reinforcement learning to optimize the language model against that reward signal. The language model generates responses, the reward model scores them, and the language model adjusts its behavior to produce higher scoring answers. This is the loop that transforms a raw prediction machine into a helpful assistant. The technical algorithm varies. Some labs use PPO, others use a newer method called GRPO, which stands for Group Relative Policy Optimization, but the principle is always the same. Let human preferences guide the model toward being genuinely useful. The results of reinforcement learning on language models are remarkable, and sometimes eerie. Models trained with RLHF don't just follow instructions better, they develop behaviors nobody explicitly programmed. They learn to say I don't know when they're uncertain instead of making something up. They learn to break complex problems into steps, checking their own work along the way. This is called chain of thought reasoning, and it emerged from reinforcement learning, not from being told to do it. The most advanced models today, like OpenAI's O-Series and Google's Gemini Ultra, take this even further. They're trained with reinforcement learning to think for extended periods before answering. They explore multiple approaches, evaluate which one is most promising, and refine their reasoning before they ever produce a response. This is reinforcement learning at its most powerful. The model isn't just retrieving knowledge from its training data. It's searching through a space of possible solutions, just like AlphaGo searched through possible moves on the Go board. Let's bring this together. Reinforcement learning is how AI goes from knowing things to making good decisions. The core loop is simple. An agent takes actions, receives rewards, and learns to maximize those rewards over time. For language models, reinforcement learning from human feedback is what turns a raw prediction engine into a model that's helpful, honest, and safe. The reward model captures what humans actually prefer, and the training loop optimizes the model to deliver it. The most powerful models today use reinforcement learning not just to align with human preferences, but to reason, to explore solution spaces, evaluate options, and think before they speak. This is the technique behind every major breakthrough in AI capability over the last 2 years. Reinforcement learning isn't just a training method. It's the bridge between a model that knows things and a model that can actually think. Next episode, we look at the tools, the open-source frameworks that let you train your own reinforcement learning models at home. Subscribe so you don't miss it.